So our first question: what is potential evapotranspiration, and explain how it is used in assessing the water balance in an area. What is potential evapotranspiration? Please give your answer and explain how it is used in assessing the water balance in an area. The concept of potential evapotranspiration was given by Thornwhite in 1948. Please remember. So potential evapotranspiration was given by Thornwhite in 1948. Potential evaporation is the amount of transfer of both moisture and the heat to the atmosphere from soil and vegetation. So it is mainly amount of transfer of both moisture and heat to the atmosphere from the soil and vegetation. So first of all, you can see in this equation, P equals to P in centimeter, potential evaporation equals to 1.6 bracket 10 T by I bracket close. Here you can see in A. So P equals to potential evaporation equals to 1 by 1.6 bracket 10 T by I and bracket close A. Please just also see, and this equation is important. You can use it in your potential evaporation calculation, bottom calculation. So first of all, I equals to sum of 12 months, T by 5 bracket close 1.514. I equals to sum of 12 months, and T equals to temperature in degree centigrade. Based on this concept, he developed four indices. So four indices he also developed: moisture index, summation 12 I equals to 1, summation, you can see summation 12 upper areas 12 and I equals to 1 lower area, and 100 S minus 60 D bracket close by potential evapotranspiration by P. So summation 12 by, please remember, I equals to 1 and bracket start 100 S minus 60 D by P. It is mainly moisture index, and it is mainly, here you can see, it is mainly the potential evapotranspiration equation. It is 1.6 first equation, 1.6 bracket start 10 T by I bracket A, and here it is moisture index. Moisture index, it is mainly summation 12 I equals to 1 and bracket start 100 S minus 60 D. But before when I see in the other equation, this is mainly potential evapotranspiration equation, and it is the moisture equation, please remember. And moisture, it is mainly 100 S minus 60 D by P, please remember. Summation start here, and S equals to monthly supply of moisture, and D equals to deficit of moisture, please remember. If we divide it, then we can take your answer. Okay, and so moisture supply of monthly supply of moisture, yes, and D equals to deficit of moisture, please remember. And P means, we know, the potential evapotranspiration. Based on these indices, he identified the humidity provinces. A equals to per humid, B4 equals to humid, B3 equals to humid, B2 equals to humid, and B1 equals to humid. Mainly B equals to humid, A equals to per humid, and C equals to moist subhumid, and C1 equals to moist subhumid and dry subhumid, and D equals to semi-arid and E equals to arid. Please remember, all the name is important: per humid, humid, moist subhumid and dry subhumid, and semi-arid and arid. Aridity and humidity indices to determine the seasonal distribution of moisture adequacy. Aridity index, here we discuss, and you can classify aridity index for humid areas and humidity index for dry areas. Aridity index for humid area and humidity index for dry area. Aridity index classification: R equals to no water deficit, and S equals to moderate summer deficit. R equals to, what is R equals to? No water deficit region. So aridity index classification: R equals to no water deficit, S equals to moderate summer deficit, W equals to moderate winter deficit, W equals to moderate winter deficit. Please remember, all the name is important. If you written long question, then I think it will be help you. So S2 equals to large summer deficit. Please remember, R equals to no water deficit, what is available means S equals to moderate summer deficit. Mainly some water is low, some water is problem, some areas water is problem, or some regions there water is not actually highly available, but it is available, so it is only S, moderate. And W is the moderate winter deficit, winter time, but S equals to summer time deficit, and W equals to winter time deficit moderately. And S2 equals to large summer deficit. S2 means large summer deficit. This time water crisis happened. And W2 equals to large winter deficit. Mainly the winter time, it is mainly water deficit time. Mainly winter deficit, large winter deficit. So dry condition, for moisture condition we discuss, and for dry condition, D equals to no surplus, and S equals to moderate winter surplus, and W equals to moderate summer surplus, S2 equals to large winter surplus, and W2 equals to large summer surplus. Please remember, AD equals to no surplus, mainly it is not surplus, and S equals to moderate winter surplus, and W equals to moderate summer surplus. So, and S2 equals to moderate large winter surplus, and W2 equals to large summer surplus. Based on the thermal efficiency index, thermal provinces were identified. A1 equals to mega thermal, C2 equals to micro, and A equals to mega, and B equals to mesothermal, B4, and C equals to microthermal, and C means microthermal, and B equals to mesothermal, all mesothermal. B means mesothermal, and A means megathermal, and C means microthermal. Thus, the potential evapotranspiration three indices were divided: aridity index, moisture index, and humidity index, which helps determine the water balance in an area. So, what we actually now see in this concept? It's mainly important concept because we understood actually what are the actual balance of water, and mainly here important parameter like aridity index, moisture index, and humidity index. They also understood us that where is the water surplus and where is the actual water deficit region located, and it's mainly determine the water balance in any area. So that's why we study it. So thank you.